Okay, good morning students. Welcome to online applied thermodynamics class. So now today in this class we will discuss the module number 3. Module number 3, that is vapor power cycles. Okay, in the previous classes in the last month we have finished the module number 1. This is the syllabus copy of our curriculum. So module number 1 is A standard cycles. So in this chapter completely we have done in the last classes, that is for 20 marks, and the second chapter of the module number 2 we have skipped, so we will do it later. And 100% of module number 3 completely we have discussed in the classes. So module number 3, there are two chapters. One is Carnot vapor power cycle and simple Rankine cycle. So this chapter will be asked for 20 marks. And another one is actual power cycle and ideal and practical regenerative cycles. That is second chapter. This will be asked for 20 marks. So first we will cover the module number 3, chapter 1, that is simple Rankine cycles. So there will be two options. You can write this question or you can answer for this question in the exams. So module number 3, so write vapor power cycles. So immediately in our mind a question arises whether both vapor and steam is both the same or different. So I will write here vapor and steam. So both 90% of the people will assume that vapor and steam both are same. Exactly, both give the same meanings, but there is slight difference between vapor and steam. So what is the difference? Can you guess the difference between vapor and steam? Yeah, so vapor is nothing but it is a substance. Even though steam is also a pure substance, vapor is also a pure substance. So vapor contains some percentage of water. So in the vapor there will be water particles, so water content, but in the steam there is 0% water. Some x percentage of water will be there, but in the steam there is no water content, that is called steam. But in some books they will write vapor or steam, both are almost same. So now, so come back to the chapter name, vapor power cycles. Now what is the definition of this vapor power cycle? So definition, first what we'll do, we'll write cycle. I will give point number 1, power to point number 2, and vapor for the point number 3. Now I will define the definition. So vapor power cycle, it is a thermodynamic cycle. The first one, it is a thermodynamic cycle. Thermodynamic cycle in which the power or energy or electricity is generated using working fluid is vapor. Can you repeat now? So vapor power cycle, it is a thermodynamic cycle in which the power or electricity is generated with the working fluid is using working fluid as vapor. So that is a definition of vapor power cycles. So before going to the next topic, Carnot vapor power cycle, now we will discuss the difference between the gas power cycles and the vapor power cycles. There are two major differences between gas and vapor power cycles. So in the gas power cycles, I will write it here. In the gas power cycle, so one is gas power cycle, another one is vapor power cycles. In the university question papers they have asked for 2 marks, but such type of questions will be asked in the interview. So, so you remember the difference between these two cycles. So in the gas power cycles, just I will glance you. So what you studied. So it consists of four processes, correct? It consists of four processes and three major components. One is compressor, another one is combustion chamber, and the third one is turbine. Compressor and turbine both are mounted on the same shaft. C for compressor and C for combustion chamber, T for turbine, and to the turbine shaft a generator is mounted, and the steam, the gas which is coming outside the turbine will be connected or sent to heat exchanger, that is HE. So these three are major components, and external one is added with four components will be there. So here, so this is, I will take point number 1, this is point number 2. So 1 to 2 is isentropic compression, and similarly 2 to 3 is heat addition process. So CC stands for combustion chamber, in which we will add the fuel. Here we are adding fuel from external source. So this fuel, maybe it may be coal or it may be petrol or diesel, any fuel. So here at point number 2, air is going inside to the combustion chamber, and this fuel and air mixes together, combustion takes place, you will get the gases. Okay, those gases are expanded in the turbine, and here low pressure, low temperature gases will get. Now you observe carefully here working substance is air, here also the working substance is air, here is also it is gas, and here is also gas. The phase of the working substance has not changed. So what do you mean by that? Phase is nothing but there are three phases. One is solid phase, second one is liquid phase, and third one is gaseous phase. But here in this gas power cycles, the phase is remain same. All the working substance entire cycle, it is in the gaseous form. It is not in the solid form, or it is not converted into liquid form. This is one major point. But in the vapor power cycle, inside the cycle, the working substance undergoes phase change. For example, in one component it will be in liquid state, in another component it will be in steam or vapor or gaseous state. So that is what one difference between the gas power cycles and the vapor power cycles. So first see here, I have written here notes. The cycle in which air is used as a working fluid, obviously that is one difference, and vapor power cycle is a cycle in which the working fluid is vapor. That is one simple difference between these two. The second one is the working fluid does not change its phase in the entire cycle. It will not change its phase, as we discussed here in the last. Just to glance what you studied in the last classes. So in the compressor it is air, that is in the gas form. In the combustion chamber it is also gas form. In the turbine is also gas form. So it is only in one phase, that is gaseous phase. But in the vapor power cycle it is not like that. In the vapor power cycle, in one component it will be in gases, that is vapor, or maybe it may be steam, and in another component it will be in liquid state. So there is a change of phase will be there. So that is one difference between these two. And third difference is it works on Otto cycle, diesel cycle, and dual cycle. As I told you in the classes, beginning of the classes, I told you gas power cycles are almost same as A standard cycles. So A standard cycle is nothing but Otto cycle, diesel cycle, dual cycle. And here the vapor power cycle, Rankine cycle. The name of the scientist who has discovered this cycle is Rankine. So all vapor power cycles works on the principle of Rankine cycle. And dear students, in some books, in standard textbooks, the vapor power cycles will also be written as steam power plant. It is also called steam power plant. Understood? Now here I will not draw the cycle now. Later we will discuss about what are the different components of vapor power cycle, etc. So here now I will write one difference is here there is change of phase. Here in this change of phase, so in one phase it will be liquid state, and when it comes to another component it will become gaseous phase. Okay, so this is one major difference between gas power cycles and vapor power cycles. So next, coming back to the second important point is how you get or how you generate vapor. How you will generate vapor? Just think, is there any device? Can you tell me the name of the device in which the vapor generation of vapor produce takes place? Yeah, obviously it is boiler. So boiler is a device. It is a metallic device in which it converts or generation of steam takes place, that is from water to steam. So now dear student, before going to the applied thermodynamics, next topic we will discuss the formation of steam. This topic you people have studied in elements of mechanical engineering, formation of steam. And dear students, now I am using the word steam because entire water will be converted into steam. There will not be any vapor or any water particles. So formation of steam. So the formation of steam will takes place at constant pressure. It may be at 1 bar, it may be at 2 bars, or it may be at 3 bar. So the formation of steam from water takes place at constant pressure. Okay, now we'll draw one simple diagram that what we have discussed in the elements of mechanical engineering. So some students, they have studied elements of mechanical, and some students, they have not studied elements of mechanical, some diploma students. So now, so this is temperature. I will take on the y-axis, and enthalpy on x-axis. H stands for enthalpy and T stands for temperature. Now initially I will take 0 degrees Celsius water. So in the container, what I do, I will take water which has a temperature of 0 degree Celsius. Okay, now I will supply heat. What I do, I will supply heat to this water. I will supply heat. Okay, so here, and this vessel is surface of the water, the vessel is closed with some weight W, so that the vapor or the steam will not go up. There will not be any deformation of the piston. So here some books they will write it as piston. So correct, piston. Okay, so now heat is added to the water which is having a temperature of 0 degrees Celsius. Heat is nothing but what? Enthalpy. Okay, enthalpy is nothing but, what is the definition of enthalpy? Enthalpy is total heat contained in the steam, contained in the working fluid. So I have supplied some amount of heat. So due to supply of heat, the temperature of water increases. So it comes from 0 degrees Celsius to 100 degrees Celsius. Now I will draw one more diagram. So A point, this will be B point, there will be piston here, it is W. Now once you supply the heat, the water particles is, this is 100 degree Celsius water. Still there is no formation of steam has taken place. Here is also water, here is also water, only the temperature is increases, but the volume of the substance has increased. Correct or not? Here the volume of the water is less, but here the volume of the water will become more, and heat is added. heat is added is nothing but enthalpy is added, enthalpy is increasing. So temperature is also increasing, enthalpy is also increasing. So I will get a linear curve. So 0 degree Celsius water is here, 100 degree Celsius. Now this point is 100 degree Celsius water. And dear students, it is at constant pressure. We are not changing pressure. It is at constant pressure. Okay. And some students mind it is maybe you have doubt that PV is equal to MRT. There is an ideal gas equation. And here pressure is constant. So because volume is changing and temperature is also changing. So it is satisfied the equation. Understood? So pressure is constant, but volume of the water or volume of the working substance is changing. So mass of the given substance is constant, R value is also constant, but temperature is changing. So it satisfied the ideal gas equation. So now it is at 100 degree Celsius water. Again you supply some amount of heat. So I am supplying heat. So now this substance, that is 100 degree Celsius water, will convert into 100 degree Celsius vapor at constant temperature. Here 100 degree Celsius water and here 100 degree Celsius vapor. Understood? It is not a superheated vapor. Still it is 100 degree Celsius, just a dry vapor, or it is just a saturated vapor. It is also called a saturated, but it is not above 100 degrees Celsius. So B to C, it is called as latent heat. Latent heat. So what type of heat you have supplied from point number B to point number C is you have supplied latent heat. Now latent heat. So latent is nothing but amount of heat supplied to any substance in which the temperature is constant. Temperature is constant. But and dear students, now here there is one change. At point number C, it is not water now, it is steam. So there is a change of phase from water to steam or water to vapor. Here at point number A, the working substance is in water state, and here is also water, but here it will become steam. So at point number C, it is steam. Here it is water. Here is also water. I will write water. But A to B, what type of heat you have supplied is nothing but here sensible heat. Sensible heat. Sensible heat is nothing but amount of heat added to a substance in which the phase remains constant, temperature changes. But in the latent heat, I have written here latent heat. Latent heat I will write. Okay. Latent is amount of heat supplied to a substance in which the temperature is constant, but there will be a change of phase from water to steam. So now it is at steam. But in the steam power plant or in the vapor power cycles, the dry saturated vapor is not sufficient to generate electricity in the turbine. So what they do, so 100 degrees Celsius vapor will be converted into superheated steam. So we will add some amount of heat will be added to this dry saturated wave steam to convert into superheated. This is superheated. This is A, B, C. I will take one more diagram here. That is D. D I will take here. Here it is steam. But here it is superheated steam. Why it is called superheated steam is the temperature of the steam is more than 100 degrees Celsius. More than 100 degrees Celsius. So from here A to B, what type of heat you have supplied? A to B, what type of heat you have supplied? Sensible heat. I will now write SH. So B to C, latent heat. And again from C to D, what type of heat you are supplied? Again, sensible heat you are supplied. So this is formation of steam. So entire formation of steam takes place at constant pressure, that is inside boiler. So 1 to 2, A to B, B to C, C to D. In some books they will write 1, 2, 3, 4, P, Q, R, S. It's left to you. It is your interest. You can take A, B, C, D or 1, 2, 3, 4. I have taken A, B, C, D here. So A to B is sensible heat, B to C is latent heat, and C to D is superheated. That again, it is sensible heat. So latent heat is nothing but evaporation. Here there is a change of phase from water to steam. So this is also called evaporation. So what is the definition of evaporation? It is a process in which the water is converted into steam at constant temperature, that is of 100 degrees Celsius. Here is also 100, here is also 100. That is called boiling of water. Now in some students' mind, one question may be arriving. Here temperature is constant, that is 100 degree, and we said that entire process is at constant pressure. So pressure is also constant, temperature is also constant. Then how volume is changing? Because M is constant, R is constant, temperature is constant, pressure is constant, but volume of the substance is increasing. How? This will be one question it will be asked in the interview. Think. And the question is to you. You browse in the Google and get the answer. Later I will explain the reason behind it. Understood my question? Here during B to C, the temperature is constant. Temperature of the working substance is 100 degrees Celsius. And during this entire process, constant pressure. But the volume, the enthalpy is increasing. Why? There is a question mark. So this is a simple procedure for formation of steam. So the entire process will take place at boiler. Okay. Now I will go to next. This is page number 2. I will go to page number 3. Vapor power cycles. Now we will come back to vapor power cycles. Now we'll start. All vapor power cycles or steam power plants, or it is also called steam power cycles.